Okay, let's continue with our lecture and discussion from the previous class. We stopped at voltage division, but I believe we didn't do the example. So let's go into the example now. All right, any questions about the derivation or how to apply voltage division? Nope. Okay. So here we have 4 resistors, 1K, 1K, 2K, and 6, and 15-volt voltage source. The first thing we do is we remove the source and we determine the total Req between the open terminals. So we have R1, R2, R3, and R4. Req, as you can see, these are all in series. So Req is simply the sum of the 4 resistances. So 10 kilo ohms. Okay. Now, typically, if you were using this larger circuit and we use series parallel analysis, we would apply Ohm's law and find the current going through there, and then we would find the voltage. Voltage division is simply an extension or a derivation from that principle. It simply allows us to skip a couple of steps. So in this case, if I wanted to find V1, V1 is a fraction of Vs, or in this case, V total. So I'm going to write Vt. And the fraction is given by R1 divided by Req. So simply 15 times R1 divided by Req, or 1.5 volts. Okay, 1.5 volts. Easy enough, right? Again, series parallel analysis, we reduce everything down to one single resistance. We apply Ohm's law, and then we simply apply Ohm's law. Sorry, we apply Ohm's law to find the current, and then we apply Ohm's law again to find the voltage across each individual resistor. This simply allows us to skip one step, right? Voltage division allows us to skip one step. We find Req, reduce the circuit down to one single resistance, and apply voltage division principle. R2 is the same as R1, 1 kilo ohm, so that is also 1.5 volts. Okay, let's take a pause. Let me know if you have any questions. And of course, the values in these examples are typically straightforward. They line up very nicely. So you can solve them by logic, or you could use logic to check your work. So even before applying the equation, we know what the voltage for R3 and R4 should be. Right? R3 is twice as much as R1 and R2. So if it's twice as much, we'd expect twice the voltage of V1. So V3 would be 3 volts, or should be 3 volts. And V4 is 6 times as much as R1. So that would be 6 times V1. Let's see if we get that or not. So V2 is Vt. Well, V2 is equal to V1. So we'll just leave it at that. V3 is V total times R3 over Req. Gives me 15 times 2000 over 10. 3 volts as expected, right? And then V4 would be exactly the same way. So 15 times 6000 9 volts. And of course, you apply KVL, you sum up the voltages, they should equal 15 volts. Again, these are all just minor things that students have to think about just so that they can verify their answer automatically. Okay. All right, 10-second pause. Any questions? Any questions at all? Okay. Then moving on from voltage division to current division. Oh, I also wanted to point this out. So several students, when I say several, 1 or 2 students from each section emailed me or got in touch with me and also received a couple of feedback about homework assignments. First and most important is about due dates. So I want to let all students know, again, I pointed this out in the first day of class, and it's also stated in the syllabus from the beginning that homework is considered assigned once the topic is covered in class. Okay, and I will expand on that statement. When I say covered in class, it means from the beginning to the end, meaning if a topic is introduced in class, I would expect students to actually look at the homework directly. So as an example, voltage division was introduced 2 days ago. So even though we did not solve the example, students are expected to open up the homework and actually go through it. See, homework is an extension of your learning in class, right? We could sit here and solve problems all day long for 24 hours a day. That's just not enough time. It's not feasible, right? So we learn something in class for an hour, and then you go home and you expand on your learning. So homework is, some of the problems will be similar to what you learned in class, but some of it and most of it should be a little bit different. You would take the principles you learned in class and you apply them to solve that homework to enhance your learning. And that is the point of homework. So it's not going to be exactly the same as what you learn in class. Not always. So when you begin the homework assignment, when the topic is introduced in class, I would expect students to again open up the homework, look at what the assignment problems are, and solve it. Some topics take 1 class to cover, some topics might take 2 classes to cover, or some topics are split. Voltage division and current division are small, but because of the time crunch or time running out, we introduced the topic, we talked about it, but we were not able to cover the example in class. So topic was introduced 2 days ago. Again, I would expect students to open up the homework and take a look at the topic or the corresponding homework. Homework assignments are all available at the beginning of the quarter for this exact reason. Okay, all of the homework assignments are dated for June, which is of course after the spring quarter is over, which is not even the end of this quarter, but even after the end of next quarter. And the reason is, if I do not have them available, students are not able to view them. So I have to have a due date on each one of those. And so I just put a due date very far into the future. Obviously, when the topic is completed in class, I will change the due date. The topics, okay, so that was with regards to the due dates. The topics are bunched together. That's another feedback I received, which again, I understand they are, bunched together at the beginning, right after the other. There's a homework due every single day or every 2 days. And the reason for that is these are all topics that are covered in your prereq classes. So prereq classes would be like the physics, I think physics 2 and physics 3. Some professors do not even like to take, because we have a lot of ground to cover in 201, we don't, some professors do not take the time at the beginning to cover the fundamental topics. I take a little bit of a different approach. I do realize it may have been some time that students have taken physics, maybe like a quarter or 2 quarters, or even a year ago. That's quite a lot of time, that has passed by. And some students might be weak on the fundamentals. Anyway, so for several reasons, I like to cover the topics in depth in class. And because we cover the topics in depth and I assign the homework for students to catch up on the fundamentals, we might teach 1 or 2 topics on Monday, another topic like 2 days later on Wednesday, another one on Friday. So the homework assignments naturally are also going to be bunched together because we are covering a lot of topics, within 1 or 2 weeks. Once we get through these first 2 chapters, the homework assignments will spread out a little bit. So in the first month itself, we would have about 8 or 10 assignments. And that's just the way the class is structured, the syllabus and the amount of material that we have to cover. And those are the, again, I think those are the 2 points I wanted to address. The homework due dates, and then the reason why the homework assignments are bunched together at the beginning of the quarter. Okay. Again, feedback has been good in the sense that I'm learning about issues that the students are facing. So good in that sense. Okay. Again, keep keep posting feedback. Again, it's anonymous. I have no idea who has written what. But if you have any concerns, put it on the instructor evaluations, and I will, I do read them every week. So again, if you have any concerns, I can address them in real time. So again, voltage division, consider that to be assigned because the topic has been introduced last class and we covered the example this class. If you have questions, you reach out to me. And my plan is to introduce current division right now and cover the example. And so consider those homework assignments to be assigned. Okay. The due dates will be updated probably like a couple of days or so, maybe 2-3 days from now. But we will again talk about a new topic on Wednesday. And so once that new topic is covered, I have to assign that homework also. And so that's why, there's like students might feel there are like 2 days or, 1 day or 2 days or 3 days, for each homework assignment. Yes. So scan homework, let's talk after class. It's there on the syllabus and I posted it online and I talked about it in the first day of class also, but it's about the work that you do for the Pearson mastering. Okay. And it's not 0 anymore. There was a glitch in the system and I reset it. I reset the system. So it shouldn't be 0 anymore. Okay. Let's see. So current division, similar to voltage division. It's derived from Ohm's law. The first step is to find Req. Once we find Req, we apply Ohm's law again to find the voltage and then to find the current. Okay. So we separate out the current source and we are left with 2 resistors in parallel. You can apply this to as many resistors in parallel as we want. Okay. So this is R1. This is R2. Req is between these terminals. And so Req is simply, well, because it's 2 resistors, I can take a shortcut and I can write product of the 2 divided by the sum of the 2. It doesn't matter what it is, but we have Req. So once you have Req, the circuit is simply one current source and I'll call this IT for total. So voltage V, simply from Ohm's law, is IT times Req. And this voltage V, because the circuit's in parallel, shows up across all resistors in that parallel network. Excuse me. So far, so good. Now we apply Ohm's law again. Expand the circuit again. Once we expand it, I1 is V over R1. V is IT times Req. Rearrange the term, and I get this equation. IT times Req over R1. Let's take a 10-second pause while you write it down, think over it. Let me know if anything doesn't make sense. Any questions? Any questions at all? Again, this is derived from Ohm's law and series parallel analysis technique, right? You reduce a large network of resistors down to one single resistor, apply Ohm's law, find the current or the voltage, then you apply Ohm's law again to find the other quantities. Voltage division and current division simply allows us to skip a step directly. If you compare this with voltage division, the principle is the same. A fraction of the voltage or a fraction of the current appears across or through that resistor. In voltage division, Req is in the denominator. In current division, Req is in the numerator. So very similar equations. In a quiz or in an exam, you can have these equations on your equation sheet, which is fine. You don't have to sit there and derive it. Okay, you can sit there and derive it if you want, but if I ask you to apply voltage and current division, then you should apply voltage and current division directly. Okay, I2 is the same. I2 would be IT times Req over R2. Okay, I2 is IT times Req over R2. And then 2 points to note, 1 point each about voltage and current division. So, is voltage being divided here? No, right? It's a parallel circuit. It's a parallel circuit, and the voltage, this point is exactly the same, and this point is exactly the same. Right? The wire can be long, wire can be short, but it's still a junction point. Right? This is all electrically the exact same point, top node and the bottom node. So there are only two nodes or two junction points in a parallel circuit, one at the top, one at the bottom. That's it. And the voltage that results, or the electric potential difference that you measure across those 2 points, is a result of all of those resistors working together. Okay, if you remove one of those resistors, the voltage will change. It will remain the same for every component, but it will change. So right now, the voltage that appears across this parallel network is a result of R1 and R2 working together. But it's the same for both. It's the same for the current source, it's the same for R1, it's the same for R2. No difference. So voltage in a parallel circuit never gets divided. Current gets divided. And of course, when we look at voltage division, it's quite obvious because there's only one path for the current to flow through. There's only one path for the current. So current never gets divided. Current remains the same. Voltage gets divided. So a series connection of components, you should automatically train your brain to think that the current would remain the same, but the voltage is going to get divided. And for a parallel network, voltage remains the same, current gets divided. So those are the two things to note. And I have just enough time to do the example. Oh, any questions? Any questions at all? All right, parallel network. Let's see, about 3.5 minutes left. Remove the current source. Find Req across the three resistances. Sorry, across the open terminals. R1, R2, R3. Someone do this calculation for me, please. So 6.667 parallel network. 2 plus R3 comes out to be 6.667 ohms. So if I wanted to find I1, apply current division directly. I1 would be a fraction of IS, the source current, times REQ divided by R1. So 15 times 6.667 divided by 10 ohms. What do we have? 10 amps, which is a huge amount of current, by the way. IS times REQ or R2. What do we get for this? And I3 is IS times REQ over R2. 3.335. 3.335, which is what I would expect depending on, looking at those resistor values. 60. And the last one. Logic tells me that it should be correct. Resistors R3, R2, and R1. Nice round numbers. Instant verification check. Resistor R3 is 2 times as much as R2. R2 is 3 times as much as R1. And so the currents flowing through those each resistors also will have a corresponding ratio. So if I1 is 10 amps, I know R3 should be 1/6. So I3 should be 1/6 of I1. 6 times as much. No, wait. That's incorrect. Is this 6.66? Uh, 1.66. 1.66. Okay. There you go. 1.66. KCL to double check. And all three of them should add up. So it's 4.9999. So 5, and 10 makes sense. So as soon as I wrote it down, one of you should have pointed out, either online or in person, should have pointed out that doesn't seem right. That's an instant verification check for your answers. All right, any questions? Any questions at all? Okay, we'll end class here today. We'll pick up on Wednesday with node voltage and mesh current analysis. Very important topic. These are the last 2 analysis techniques in chapter 2. It's going to take at least a couple of classes, if not more, to cover those. All right, consider the homework assigned on these 2 topics. I will change the due dates on the Pearson homework, or change or bring it forward from June.